Hey, welcome back. In the last tutorial I showed you guys how to make a simple teleporter using the action system. You can see that it works here, that we're teleporting instantly to another tile like this. So in this tutorial we're going to make it a bit fancier, make it work better along with our movement system, with AI and so on, and we're going to learn a bit more about actions along the way. So let's get on that. First, let's pretty it up so we can add an effect when we are teleporting. So I want to add an explosion effect, like a particle effect, when we are teleporting, so something happens. So we can do this, of course, within the action. So I can add a particle effect that happens at the start here, and that's probably the best way to do it. But in order to show a bit more about the action system, I'm going to do it a different way, at least initially. So if we're doing multiple actions here, so I can add another action before this action. I can create a new action for creating a particle effect. And maybe it makes sense to have these things separate. Maybe you don't always want to have a particle effect in your teleporter. I mean, you could have that also specified in your variables, whether you want a particle effect or not. But yeah, just in order to demonstrate here. So should we create a new action then for creating a particle effect? Well, we can, but that's one of the things that's already in the toolkit. There are many actions that are included here in the actions folder, and many of the ones that are like generally useful are available through the action manager. So we can actually here get the action manager, get action manager, and then we can search for queue, and you will find all of the actions that are used for queuing also under this action tag here. So this is the naming convention that I'm using for any function where you want to add something to the action queue. You might want to use the same naming convention, but that's up to you, of course. So we can use the queue spawn emitter function here. And all it really does, if we go into this in the action manager, you can see that it spawns this actor, which is the spawn emitter action, and adds these inputs. So this is a if you have any actions that you're using a lot, then it might be useful to add them within a function in an actor like this. You can have this, in the action manager or whatever action that you choose, but this way it's simpler to queue them, and you don't have to, split this pin or anything like that, and you can keep just the inputs that you need. So we want to spawn an emitter. I want to use the explosion emitter here, and I want to spawn it at the location of this initial teleporter. Remember, we want to use then the location of the grid anchor, as I explained in the last video. So I could get the transform here, but I actually want to modify the scale. So we end up splitting a transform anyway, but not for the same reason. Okay, because I know that this explosion is a bit small, so we'll scale it up by 2. And yeah, we'll add a sound because this is something I've added to the spawn emitter. Anyway, let's use the fire blast. And there we are. So let's see, we should now have an explosion there when we teleport, but it happens a bit quick. We can do better. So let's go to the teleport action, and what I want to do here is actually to hide the puppet for a bit as we're teleporting it. Give it a bit of a delay. That's one thing that's useful in actions, is that you can add delays and all of that, and it will not continue until you call end action. So you can just do whatever you want within here. So let's set this puppet to hidden in game. Set that to true. Then we will wait like for a second before moving its location. And then after moving, we want to wait yet another second before again revealing the puppet. Well, let's see. So if we try it now, we go here, we disappear, move over, and we appear back. Now it's a bit jarring when he reappears, so let's add a particle emitter here as well. So again, the simplest way to do this is simply to use the spawn particle emitter, the regular, what is it called? Particle system. Is that the one? Oh, it's spawn emitter. Yeah, spawn emitter location. I mean, this is the simplest, but why do it simple when you can do it difficult? At least to demonstrate the action system. So, what if we want to add this action that we have? So this spawn emitter action, and we want to use this within an action. Can we have like nested actions, actions within actions? And we can, but you have to follow some rules for that. But let's demonstrate. So for this, I can't use this queue spawn emitter function for the simple reason that I have not chosen to give access to this activation input here. I could have done that, but I have not. So let's use the regular spawn action here. We'll just copy it in so it's quicker. So yeah, within the teleporter. So instead of, let's see, within the teleport action, I mean. So we can spawn this action emitter here, action spawn emitter, and we will again choose our explosion, and for the transform, we're gonna get, since we have moved the puppet, we can just get the, or we can get the target location actually. And so the target location, and we will again increase the scale. We will add our fire blast sound, but we can't queue it in here because that doesn't really make sense. Because we're also queuing an action that is adding it to the queue. So at the point that you are spawning an action, it is added into the action manager in the action queue array. So if we're queuing this when we're playing this action, then it actually happens at a point that's very unpredictable for us. And if we have queued other actions beforehand, those will all play before we get to this action and so on. So it doesn't make sense to spawn it here. Also, if you're making a network game, it makes even less sense because this play action event happens on the client and you only want to spawn actions or add actions to the queue really, so have queued actions on the server. But you can set an action to immediate, and if you place it on immediate, that means that the moment it is spawned, play action is automatically called, and as soon as it is done, then this action is automatically destroyed. So it circumvents the entire action queue. It's never added to the queue, so it happens immediately instead. So we can use this then after the delay to spawn this emitter. And let's see if that works. We go here. Yeah, and it didn't. Let's see what went wrong here. Oh yeah, we did the spawn transform location, of course. So my bad. This is the one we want to change. That's not a mistake I made on purpose. And there we are. Okay. You may have noticed that there was a last option here for activation. It's the manual one. What this does is that then this action is just spawned into the world like a regular actor, and it's never added to any action queue. It is not played automatically or anything. So it does basically nothing until you tell it to. This is something you can use for more advanced sort of stuff, but I won't get into that in this video. But let's also delete this and do it the most sensible way here, which would be the to spawn an emitter at location and just use the explosion, and then play sound at location, and use the fire blast for this. And since we are within this action, we can just do it like this, and it should work just the same. Let's just increase the scale. And there we are. That's much more sensible. But then you know at least how you can use actions within actions. If you have some sort of complex functionality that you have within an action that you don't want to, you know, repeat and do again, then that's one way you can do it. Inside of actions, or really anywhere that you want to when you don't want to have it queued. Okay, so let's just clean this up a bit, and we'll call this action done. Good. Okay, so we've got our flashy teleport, but and it looks a bit like what you might recall from the start of the last video, but we're not all the way yet. If you remember from that, we were able to actually hover our mouse over the end of the teleporter here, and the pathfinding would understand how it could move from one point to the other. It doesn't work like this right now. It only works when you end your movement on it, and the AI will not be able to understand or make use of this teleporter either, because it's not really part of the pathfinding setup. So it will just, if a player unit is standing next to the teleporter pad here, it might try to attack the player and become teleported away instead, or become confused like that. So this won't work with the AI at all, and it could be more interesting in terms of having the player be able to see the tiles they're able to move to on the other side of the teleporter. So let's add that next. To do this, we'll have to modify the grid edges. So the grid edges, though, that is a map variable within the grid manager, which holds what tiles are connected to what other tiles. So by default, at the start of the game, each tile will be connected to its neighbors. So this tile here will have 6 edges, and all of them will have values that represent the indices of these tiles here and the costs for moving to them. So to be able to, for the pathfinding to understand that we can move between these two, we have to add edges between these teleporters. So to do this, we have to modify our teleporter blueprint. So let's think about how we can do this. Well, in the teleporter, we can do this at begin play. So if we get our grid manager, there is a handy function for just this, so we can use the add edge both ways, and this will connect 2 tiles based on their indices to each other. So we can get the tile index, the grid index of this teleporter, and we will also get the grid index of our paired teleporter, and we'll have a cost of 1, let's say, why not, for moving between them. So yeah, maybe this should work, but yeah, it won't, and I will explain why. So I can just show that it doesn't. We can't move to this. Pathfinding doesn't understand that these are connected. So the reason for this is that now we're doing this at begin play. So we're doing it at the first tick of the game and adding this edge. We don't have control in which order the grid manager generates all of the edges that it sets up by default at the start, and when this is done. So we want to make sure that we don't have any race conditions here where we end up, because if this is called first and then the grid manager runs its setup, which is done, by the way, and yeah, let's go to the main grid manager in the event graph, and you see this setup grid arrays. So this, if this is called after we call this, then this will be overridden. So we need to make sure that we're calling add edge both ways after this has been run. Now, if you're watching this after the next hotfix, I am planning to add an event dispatcher call here when the grid manager is done. So you can bind this function here, or an event that calls this function when the grid manager is done processing. That would be the best way to do it. So if you're watching this in the future, do this. But yeah, at the moment we can use this instead, not as ideal, but it'll do the job. So we have a boolean that is set to grid setup done for the grid manager, and in the teleporter here we can get our grid manager and get our grid setup done. And if it is not done, we want to wait until it is. So we can use delay while, which is a custom macro that I've made, which is available to all actors. So we wait until this is done, and then we keep going. So the reason this is worse than using an event dispatcher is, well, for one, it could be called multiple times. This is called every tick. It won't, because this happens during the first tick of the game. But yeah, that's one reason why. And the other is that this will happen on the next tick of the gameplay instead of the same tick at which it happens. But yeah, this works perfectly fine for our purposes, because as long as this happens at least before the first unit is activated, and that will always be the case, then that is fine. So let's see if it works. Okay, you can see now that these tiles are actually connected, that it's possible to move between them. Now it looks like we are moving at all of these tiles in between, but actually that's not what's happening. The cost now from moving from this tile to this tile is 1, and they're actually moving directly, even though it looks like they're moving through the entire thing, as we can see now. And of course it's not teleporting at all, because you only teleport when you end up at a teleporter. But gameplay logic wise, this is exactly what we want. It works fine now for the gameplay logic, but it needs to look right for the player, for the game to work right. So we need to get on that. So instead of binding this event to the end of movement, we want to bind this event to whenever the unit enters the tile at all during movement. So instead here we bind events to, let's see, always a lot to look for here, on unit enter, bind event to on unit enter, enter tile simulate instead of end movement. So we'll bind this event instead, and they have the same inputs, so we can just bind it directly like this, and it should work well. But I have a feeling this is going to look real weird. Let's see what happens if we try to move. Yeah, we get our teleportation, and then he's moving, and we're teleporting back again, and then he continues movement from here. So this looks pretty bizarre, and I'll try to explain what is happening here. So yeah, whatever is going on now, let's just enter play again to see. What you might expect to be happening here is that we have a move action. So we have an action that is queued, which is that we want to move through this entire spline here, and that's one action. And then, but at the moment where the unit enters this tile here, we get a teleport action that is queued. And then when the unit is teleported over here, he enters this tile, which means that it's teleported back again here. So if movement was just a single action, what you would expect to see is to see the entire movement here from start to finish. Then you'd see the teleport from here to here, and then you'd see the teleport from here to here. But this is not what we're seeing, right? Just to show again what's happening. We're seeing that we're actually, this teleport happens the moment that we enter this tile, and then the moment where we enter here, and then it continues from here. And the reason for this is that the movement action is actually a bit special, and I'll show how it is, in what way it is. Let's edit our debug unit here. This is a child of BP unit anim, so let's look into this blueprint. So BP unit anim, that's a child unit of BP unit, and it doesn't have much stuff, it just has a few things for animation. And one of the things it has is this, it overrides the simulate enter tile function in BP unit. So this is the event that in BP unit handles like moving the reference of the unit on the virtual grid. And we do this as well in this anim blueprint, but we also queue an action to actually show our movement. And this queue or extend move action is what it's called. So it's a bit weird, but I thought I should cover it here because it might be useful for people to understand. So I have made this special in order so that if it is interrupted, so if during movement a new action is queued, then the move action is actually automatically split into multiple actions on either side of the actions that are interrupting it. And that can be any number of actions. So to show how this works here is that every time a new tile is entered during this movement simulation, which is in the gameplay logic, happens instantly, it checks, okay, so the previous action at this point, or I mean the last action that was added to the queue, which you can get by doing this, is this a move action? And if it is, then we keep adding locations to the current move action. So we're actually, the first time that this action is queued, it goes and checks, do we have a move action yet? When we simulate the first step of entering a tile. And of course we see no, so then a move action is spawned. And the next time when the simulation tries to enter a new tile, it checks, yeah, we already have a move action actually. So we're just appending locations into our existing move action. And we keep doing that unless we see that the last action that was queued is actually not a move action. And this tells us that the move action has been interrupted. So at this point we spawn a new move action, which is then added after this previous action that we have queued. And then we start appending to that action. So yeah, hopefully that was clearly explained. This is a bit complex, but this is how it is set up, so that the move action, we automatically spawn a number of move actions that is needed, so that they can be played on either sides of any actions that interrupt our movement in the meantime, which could be something like walking onto a trap or overwatch fire, or in this case moving onto a teleporter. But as we see with the teleporter, since the teleportation is a kind of movement in itself, we're getting some pretty weird results, so we need to take care of that. So first thing we need to take care of is that the unit is not teleported back when it's entering the second teleporter. So we can, there are many ways we could do this, but let's try a simple way here. We can make it so that the teleporter can tell the other teleporter to skip the next time it's gonna teleport when a teleportation happens. Look at that, saying teleport a lot of times now. Okay, so we add a variable which can be skip next teleport. We'll make this a boolean, starting with a small b here as per Unreal Engine naming standards. That's up to you. So when we are teleporting, we want to get our paired teleporter, and we will set skip next teleport to true. And here, if we're checking that everything is okay and we are supposed, let's give ourselves some space again. So if we are going to skip the next teleport, for cleanliness, let's just add a not. So if we're not skipping it, then we're going through with all of this stuff. If we are skipping it, then we're setting skip next teleport to false. So this should make it so that we're telling the other teleporter, don't teleport us directly back when we're moving on to the teleporter after the teleport. And this will be called again immediately after the unit is teleported to the next, to the second teleporter. And then this will trigger and it will set it to false again. So we will be able to teleport back the next turn if we want to. But it's still gonna look weird, but we're not gonna get the double teleport at least. So what happens now is that we teleport over here, but then movement is still happening all the way down here. So we need to skip this movement here. So this movement action, which is a single move action between these two, we need to make sure that this is never queued. So how do we do that? Well, the simplest way to do that is probably just to modify our queue or extend move action function in our BP unit anim here. So yeah, I know we're doing a lot of stuff here, and if you haven't used the toolkit a lot, yeah, I should come with a disclaimer here that not everything you do is going to be as difficult to work with and modify as this. I've purposefully chosen stuff that's pretty complex so that I'm able to show a lot of different systems and a way to work with actions. So I hope you're not too intimidated, but this way I hope I can show many different things you can do, many ways you can work with the toolkit. So yeah, small digression. But yeah, so we want to modify this function, but maybe you don't want to modify this unit here directly. You want to keep it as it is in case you want to look at it later. So we can make a copy or we can make a child blueprint of BP unit anim for this. So let's find BP unit anim. Let's actually make a child of the debug unit, so we can keep these colors that are automatically set for the faction and so on. Just since we're doing this for a tutorial, so we'll call this then. It'll have a long name if we want to do this proper. So BP unit anim debug and teleport. That's a long name. So in this we can override our cure extend move action function. We can override it here. We should be able to find it. There it is. And we want to keep all of this code actually as is. We just want to add some new code that lets us skip this behavior if we need to. So we can tell this to, if we have teleported, then skip the next move segment that is queued. So we can add a boolean for this. So we can have skip next move action, and we can check this at the start here. You can hold B and click to get a branch, by the way. That's a quick and easy way to do this. So if we're skipping the next. If we're not, then we continue as normal. If we are, then we set this to false and then return. So yeah, similar to what we did with the teleporter here. So we can tell this unit to skip. So next we'll need to fix that in our teleporter. So when we have teleported our unit, we can do this after we've done all of this other stuff. We can get our unit, in this case, not the puppet. Yeah, just to do it quick here, let's just do this as a sequence. I should probably set this as a variable, but let's do it quick like this. So then to access this new variable, we'll need to cast it to our teleport, our debug teleport unit. And then we want to set our skip next move action to true like this. For this to work, we of course need all of our units to be of the proper class. So let's just mark all of our units here, and we can right click them and we can replace them with the debug teleport version. There we are. And if we hit play, oops, if we hit play, okay, something weird is going on here. Yeah, that's on me for being lazy. Okay, so since we're doing this in a sequence here at the start, I'm doing this every time. Every time this on unit enter tile simulate is called, I am setting this to true, which will give us some strange results. So yeah, let's just do it ugly like this. I can't stop myself, have to at least clean it up tiny bit, right? But yeah, so let's do it at the end here. So now this is only set if we're actually teleporting. And now, hopefully, it should work. Here we are, and the teleporter is working. Fantastic. So we're almost done. There's just one small thing remaining, and that's AI. So will this setup work with the AI? And I know for a fact that the answer is no, but there's just one small thing. But let's see if it or how it currently works. So if we move the teleporter all the way over here, and we'll just delete a couple of our guys just to make our turn end quicker. And if we start now, we can see that we are able to teleport all the way over here, but does the AI understand that they can use the teleporter? And if we end our turn now, we can see that, yeah, in fact, they do use the teleporter. But as you can also see, they are not attacking us for some reason when they are exiting. They're just moving as close to us as they can. So why is this? To find out, we need to look into the AI code, which is within the abilities that the AI is using. So all the units here are using this default ability, which is the ability called Move Attack. So Move Attack, it doesn't really have much AI code of its own. It has some custom AI code if no valid targets have been found. So if during the regular AI calculations this ability finds no valid targets, then it tries to move as close to a target as it is able to do. So hopefully it will get close enough that next turn it can attack. And that's what we're seeing here. He's moving all the way. They're moving as close to us as we can. So for whatever reason, this AI thinks that there are no valid targets. And why is this? So to find out, we have to look into the parent ability, which is BP ability, which holds the AI which it's using. So when an ability is activated, then if it's a player, then we get this player activation. The AI, it gets its own thing. It assesses this ability and tries to figure out the value of the ability and also the targets of this ability. And so it tries to find any targets. So as part of this AI tries to find all possible targets that it can attack. And in this code, the first thing that happens is that it finds potential targets. It finds all targets that it can reach with its ability. And to do so, at the very start of this function, it tries to find all the units that are potentially in range, just to start as a very rough filter, so that it can do more complex calculations on these units. And to do this, it looks in a range which is equal to the move range of the ability or the unit and the attack range of the ability. So normally this will make sense, right? Because you will not be able to attack or use an ability on something that's further away from you than your move range plus your plus the attack range of the ability, right? But since we added the teleporter, now that is actually possible, and that's what's happening now. So it's failing even though it shouldn't. So we can lazily here just override this and put this range to something super high. You can do this in a cleaner way, of course, but it works fine here. Should we modify BP ability directly, or should we do this in a child actor? I mean, it's up to you if you're doing this sort of thing, but if you are making a game that has teleporters, then this filter function will obviously not make any sense anymore. So we're just doing it like this, quick and dirty for now. So since this is not a video about AI, and now finally it should work properly, or so I hope. So let's click end turn and look at the AI go, and they are attacking. Excellent. So I'm lucky that, or the AI is lucky that the melee units went first. If the ranged unit went first, he would probably stop here and then prevent the other guys from teleporting. But yeah, I guess they were more clever than what I programmed them to be at the moment. So great, now that is our teleporter. Okay, hope you found it interesting and that you learned something particularly about the action system. I plan to make more videos explaining the action system in more depth as well, and other aspects that we have visited here. And I hope you found this video to be useful. I try to here combine showing how you do things practically with the theory behind how the action system works. I don't know if this is the way that is most useful for people to learn or not, but so if you would prefer that I have more of these old types of videos I've made before, where I go through more of the blueprints and explain the reasoning behind them, and have separate videos where I do these sorts of experiments and try stuff out, then and you think that is better, then please let me know. If you think this combination of both is better, then also let me know, and I'll take that into consideration as I keep making new videos. So yeah, I hope you found this interesting, like I said. So, and as always, if you have any questions, then you can ask me in the support thread, which is linked in the description of this video. If you have quicker questions or want to ask other people using the toolkit, then swip by the Discord, which is also linked in the description. Or if you have any questions that are specifically tied to this video, then feel free to post them in the comments of the video. And is this the point where I ask you to like and subscribe? I guess I've never done so, but yeah, consider that if you want. Okay, thanks for now.